Hi, I'm Carl Cook, president of IntelliDynamics. We help industrial operators improve real-world performance using field-proven industrial AI, built for operational realities, not lab conditions. Our chorus is simple: field-proven industrial AI for operational excellence. That means measurable outcomes, governed adoption, and sustained performance that sticks. Most organizations don't struggle to start an AI initiative. They struggle to get something that operators trust, engineering can validate, and the business can rely on month after month, year after year. Industrial processes don't run on magic. They run on constraints, instrumentation, procedures, and reliability. So industrial AI has to meet that standard. We serve asset-intensive, process-driven operations. The kinds of environments where downtime, off-spec product, energy waste, and instability are expensive. Historically, our strongest concentration has been in oil and gas, but we've fielded systems across aerospace, manufacturing, refining, chemical manufacturing, and steel in both discrete and process industries. What we deliver is an operating capability: understanding, 2, prediction, 2, optimization. Understanding means what's really happening in the process right now, including constraints and the quality of the measurements. Prediction means what's likely to happen next, early enough to act. Optimization means improving outcomes while respecting safety, equipment limits, and operational reality. Platforms can be useful. We have our own platform called Intellect. But in operations, the real question isn't, do you have a platform? It's this: does it produce a sustained operating capability in the field? Operational AI has to work when conditions are imperfect. Sensors drift, equipment degrades, maintenance changes behavior, processes foul and clog, constraints move. So we build systems that are resilient and governed, not fragile. A simple design principle keeps you honest. AI should be additive. Optimize when it's on, run safely when it's off. That's separation of concerns, lower operational risk, and graceful degradation. We don't believe in huge initiatives. We start with a defined scope and a specific capability, prove it in the field, and expand from there. For example, in oil and gas, we often start with virtual metering, creating trustworthy estimates where direct measurement is limited or expensive. From there, we can expand into broader prediction and optimization, because you're now operating with better, more reliable numbers. We've been doing real-time industrial AI in the field for decades. A few proof anchors that matter to operators: systems producing nightly regulatory production accounting reporting on schedule for a decade. Multi-column control, where in-spec operation improved from 18% to 58% with a 3-month payback. Discrete parts aerospace yield improvement from 40% to 100% pass, with the customer winning an award. Long-run sustainment, models maintaining 90% accuracy after 10 years on an offshore asset. The difference between a pilot and an operational system is governance, monitoring and drift detection, change control and validation, clear ownership and accountability, operator workflow, fit and trust. If you don't have operator trust, you don't have a system. You have shelfware. Here's how we like to work. Identify a high-value need with clear operational scope. Start with the smallest capability that solves it, often prediction first. Prove it against reality. Put governance around it. Then expand into performance improvement and optimization. This approach is faster to trust, lower risk, and easier to sustain. If you're exploring industrial AI and you want results that hold up in real operations, we should talk. I'm Carl Cook at IntelliDynamics. We build field-proven industrial AI for operational excellence, measurable outcomes, governed adoption, and sustained performance. Links and contact details are in the description. Thanks for watching.